All right. For those of you tuning in later, I am going to tweet this out so that people can join me if they want. Paper reading stream again today. All right. This is Paper Club. Today, I have a big backlog of papers that I need to keep up on. And I decided that I need to do more regular paper streaming because otherwise I won't hold myself accountable for reading these things. If you're new here, this is something I do maybe once a week, but I haven't been that, I guess, disciplined on it. Anyway, so I have a cluster of 3 papers. I get my papers from Papers Read on AI. This is relatively good at curating the stuff that everyone's talking about. Sometimes it has misses, like happened last paper reading session that I streamed. But I think these are relatively well reviewed. So we'll at least have to be familiar with them, even if they don't necessarily change my life. I do want to be familiar with what they're saying and what they're promoting and just be somewhat familiar. So it's the Agents paper, which is not at all confusing. The AutoGen paper, which I've actually seen some momentum since it was published. So this is a good one to know about. And then AgentTuning, which I haven't heard it at all. So I'm expecting to dismiss some of these out of hand, but it's good to just browse through and get a sense of how important they are. And then a little bit of my process, I guess I just play the audio while I read. This tends to be a very lossy process in the sense that I will pause every now and then to try to read up. I don't know what AI Waves Inc. is. Zhejiang, I know, but I don't know AI Waves Inc. AI content generator. That is not good. Okay. All right, so then we play the paper and let's see what happens.
Is the ability to use external tools and Papers Read on AI with Rob, keeping you up to date with the latest research. This reading is brought to you by Mars Race. Stake a claim on the red planet. Rinmai Sachin. Abstract. Recent advances on large language models, LLMs, enable researchers and developers to build autonomous language agents that can automatically solve various tasks in interactive environments, humans, and other agents using natural language interfaces. We consider language agents as a promising direction towards artificial general intelligence and release agents, an open source library with the goal of opening up these advances to a wider non-specialist audience. Agents is carefully engineered to support important features including planning, memory, tool usage, multi-agent communication, and fine-grained symbolic control. Agents is user-friendly as it enables non-specialists to build, customize, test, tune, and deploy state-of-the-art autonomous language agents without much coding. The library is also research-friendly as its modularized design makes it easily extensible for researchers. Agents is available at https://github.com/iwaves-cn/agents. 1. Introduction. An autonomous agent is a system situated within and a part of an environment that senses the environment and acts on it over time in pursuit of its own agenda and so as to affect what it senses in the future. Is it an agent or just a program? A Taxonomy for Autonomous Agents, Franklin and Gracer, 1996, Large Language Models, LLMs, Brown et al., 2020, Yang et al., 2022, OpenAI, 2023, such as ChatGPT make it possible to build autonomous agents that can automatically solve complicated tasks and interact with the environment, humans, or other agents by perceiving, reasoning, planning, and acting in the world. Wang, 2023. Are a promising step towards artificial general intelligence (AGI) and can help reduce human effort in certain roles such as customer service, consulting, programming.
That's Lillian over there.
Some recent demos such as AutoGPT, Richardson et al. 2023, and Baby Aggie, Nakajima 2023 have demonstrated the potential of language agents and have gained massive interest from developers, researchers, as well as more non-technical audiences. While intriguing, most of these demos or repositories are not friendly for customizing, tuning, and deploying new agents, even for experienced developers or researchers. This limitation comes from the fact that these demos typically proof of concepts showcasing the possibility of language agents instead of being larger frameworks that can be used to build and customize language agents over time. Moreover, most of these open source repositories only cover a small portion of the core abilities of language agents, including task decomposition. Nai et al. 2022, long short-term memory, Joe et al. 2023, web navigation, Nakano et al. 2021, tool usage, Shake et al. 2023, and multi-agent communication, Forster et al. 2016. In addition, most, if not all, existing language agent frameworks solely depend on a short task description and rely completely on the abilities of LLMs to plan and act. This results in significant randomness and inconsistency across different runs, delivering an unsatisfactory user experience and making it hard to customize and tune language agents. We believe the aforementioned limitations are important barriers for recent advances in language agents to reach a broader non-specialist audience and impact our society in a positive way. To this end, we release Agents, an open source library and framework for language agents dedicated to supporting LLM-powered language agents. AGENTS's philosophy is to make customizing, tuning, and deploying language agents as simple as possible, even for non-specialists, while also remaining easily extensible for developers and researchers. In addition, the library also provides the following key features that make it a versatile framework for language agents. Long short-term memory, according to Franklin and Gracer, reference 1996. A key difference between autonomous agents and computer programs or machine learning models is that machine learning models only need to respond to a single input query, while autonomous agents need to interact with environments or other agents over time. Therefore, the ability to maintain long short-term memory is very important for autonomous agents. Agents integrates the memory components in Joe et al. 2023 and enables language agents to store and retrieve long-term memory with vector DB and semantic search and regularly update a short-term working memory with a scratchpad. Users can choose to equip an agent with long-term memory, short-term memory, or both of them by simply filling in a field in a config file. Tool usage in web navigation. Another important feature for autonomous agents is the ability to use external tools and surf the internet. This is especially important for language agents because they rely on language interface and thus need to use external tools to interact with environments beyond language communication and navigate the web to gather useful information. Following Pilot et al. 2023, Agent supports a few commonly used external APIs and provides an abstract class that enables developers to integrate other tools with ease. We also enable agents to navigate the internet and gather information by defining web search and web navigation as specialized APIs. Multi-agent communication. In addition to single-agent abilities, Agents also supports customizing multi-agent systems, which can be helpful for certain applications such as games. Spark et al. 2023, Social Experiments. Lee et al. 2023, Software Development. Gian et al. 2023, etc. One new feature for multi-agent communication in agents is the dynamic scheduling feature. Instead of scheduling the order for the agents to act with hard-coded rules, dynamic scheduling provides an option to define a controller agent that acts as a moderator and decides which agent to perform the next action considering their roles in the current history. Dynamic scheduling has the potential to make communication between multiple agents more natural and flexible. Developers can easily customize the controller by specifying its rule in the config file using natural language. Human-agent interaction is one limitation.
So I'll comment on this one that dynamic scheduling is something I've been looking for inspiration on, and this seems like the first one to actually tackle that. So be interested to dive in that code.
Agent interaction. One limitation in existing agent frameworks is that while they enable agents or multi-agents to automatically solve tasks, it's not easy or even possible for human users to interact with the agents, especially in the multi-agent scenario. Agent seamlessly supports human-agent interaction in both single-agent and multi-agent scenarios, making it possible for one or more humans to communicate and interact with language agents. Controllability. Existing agent frameworks generally define and control the agent's behavior only using a system prompt and then let the agent plan and act on its own. In contrast, agent provides a novel paradigm to build controllable agents via symbolic plan, also referred to as standard operating procedures (SOPs). And SOP is a graph of multiple states that defines different situations an agent may encounter while accomplishing tasks and transition rules between states, similar to SOPs in the real world. An SOP agents is a meticulously documented set of step-by-step instructions that outlines how a particular task or process should be performed by an agent or a group of agents. SOPs can be generated by LLM and edited by the user when customizing and tuning the agent. After deployment, an agent will behave following specified instructions and guidelines for each state and dynamically adjust its current state according to its interaction with the environment, humans, or other agents. The introduction of the symbolic plan offers the opportunity to provide fine-grained control of an agent's behavior, making agents' behavior more stable, predictable, and facilitating tuning, optimizing agents at the same time. Agents is an ongoing effort maintained by researchers and engineers from AI Waves 2. We look forward to support from community contributors on the project. The library and detailed documentation and tutorials are available on GitHub. 3. 2. Related work. 2. 1. Autonomous language agents. The concept of language agents has become very popular recently, and a variety of language agents targeting different tasks have been proposed. For example, generative agents. Spark et al. 2023 developed language agents to mimic human social behavior. Web agent. et al. 2023 demonstrated the possibility to build language agents that can complete the tasks on real websites following natural language instructions. Gian et al. Reference 2023 and MetaGPT. Hong et al. 2023 experimented with software development in multi-agent communication settings. And Joe et al. Reference 2023 built language agents that act as interactive writing assistants. In addition to language agents that target specific tasks, recent open source projects such as AutoGen, Richardson et al. 2023, Baby Aggie, Nakajima, 2023, and Super AGI, 2023 are aimed at the goal of building autonomous agents that do whatever users want and attract massive interest from both developers and non-specialist audiences. 2.2 language agents frameworks. More recently, a few open source frameworks for language agents have been proposed. For example, Transformers Agents, Wolf et al. 2020 builds language agents that can automatically use tools to solve tasks described in natural language. LangChain, 2022 supports end-to-end language agents that can automatically solve tasks specified in natural language. Campbell, Lee et al. 2023, and AgentWorks, Chen et al. 2023 are platforms tailored for building multi-agent systems. Gentlelia, Xu et al. 2023, and Xlang 4 are libraries for building tool augmented agents. We illustrate the key features supported by these platforms and agents in Table 1. We can see that Agents is the only framework that supports tool usage, long short-term memory, and multi-agent communication at the same time. Agents also offers human-agent interaction and controllability through symbolic plans, SOPs, for the first time. 3. Library design. Agents is designed following philosophy in Franklin and Grazer, reference 1996. An autonomous agent is situated in an environment. Therefore, agent and environment are two major classes in the agents framework. In addition to these two classes, we also include a class for symbolic plans, named SOP, short for standard operating procedure, to make language agents more controllable. These main classes are all initialized from a config file, which can be filled in plain text. In sum, a typical script for initializing and running a multi-agent system with agents is illustrated in code 1. The config file not only defines these core objects, but also factorizes complicated prompts into modularized prompt components. The factorization of prompts significantly reduces the expertise requirements and efforts for users to build multi-agent systems. Using a single config file to define the agent's plan and basic environment also facilitates the sharing of language agents, which will be discussed in the Agent Hub section. Each of these three core classes consists of standardized APIs that can be overridden by experienced developers and researchers. We describe these classes in detail. 3.1. Agent. The agent class abstracts a language agent. Its UML is illustrated in figure 1. We can see that an agent maintains its long short-term memory and has methods to observe the environment. Agent _ observe environment act according to its current state. Agent _ act and update its memory. Agent _ update _ memory. All these methods are wrapped in the agent step method. This factorization enables developers to customize agents with new functionalities easily. Unlike existing language agent frameworks that assume agent must be based on an LLM, we include _ is human property to an agent. If it is set to true, the agent _ act will have to provide observations and memory information to a human user and wait for the human user to input the action. This design allows flexible human-agent interaction in both single-agent and multi-agent systems by allowing human users to take the role of one or more language agents. It facilitates developers to build various interesting applications, such as allowing human users to act as members of a team and debate and collaborate with agent or human-based teammates to be another team, or act as CTO engineers in a software company and collaborate with others for software development. 3.2. SOP. The SOP class contains a graph of the states of agents. Each state specifies a certain subtask or sub-goal of all agents when accomplishing the task described by the SOP. States are abstracted into a state class. A state object contains modularized prompts for the agent to leverage an LLM and various tools or APIs that an agent can use in a state. We abstract everything an agent may use for action in a state into a component class. The component class consists of two subclasses corresponding to different parts of the prompt and tools or external APIs, named prompt component and tool component, respectively. Prompt component includes modularized prompts that specify the task goal, rules, constraints, step-by-step demonstrations for in-context learning, and the output format. Tool component supports more complex usage beyond modularized prompts, including external tools and APIs such as web search, knowledge bases, etc. The results of the tools are either included in a prompt or directly returned and processed afterward, according to the config file. And SOP object also includes an LLM-based control function that decides the transition between different states and the next agent to act. The state transit function is named SOP _ transit, and the agent routing function is named SOP _ route. Both of the functions are wrapped in SOP. Next function, which is used in the main loop. 3.3. Environment. The environment class abstracts the environment in which the agents are situated. An environment consists of two main functions: environment _ observed and environment update. Environment _ observed defines how the environment environment influences the agent's action, i.e., what information should be transferred to the agent upon observation. Environment update defines how the agent's action impacts the environment. The execution logic of a multi-agent system based on agents is very intuitive. As illustrated in code 2, in each iteration, the soft first decides the state transition and selects the next agent to act based on the agents in the environment. The agent then takes an action based on its state in the environment. Then the environment updates itself based on a new action. Finally, if a workflow requires dynamically adjusting the plan based on the intermediate execution results, one can parse the output from an action, define a new state, and add it into the current SOP. 3.4 Implementation details of core features long short-term memory. Agents implements long short-term memories for language agents following Joe et al. Reference 2023. Specifically, long-term memories are action histories and are embedded by sentence transformers. Reimers in Gorevic 2019. Stored in a vector DB and queried via semantic search. Short-term memories or working memories are in natural language form and updated by an LLM via carefully tuned prompt. Tool usage in web navigation. Agent supports tool usage in web navigation via tool components. For each external tool or API, developer can wrap the API call in a tool component. Func method. For complicated tools in which the API call is context dependent, agents integrates the function calling feature of OpenAI's GPT APIs to let LLMs decide how to use the tools. Web navigation is achieved by implementing web search as a specialized tool. Multi-agent communication. Different from most existing frameworks for multi-agent systems that use predefined rules, e.g., let each agent act in sequential order to control the order for agent's action. Agents includes a controller function that dynamically decides which agent will perform the next action using an LLM by considering the previous actions, the environment, and target the current states. This makes multi-agent communication more flexible. Human-agent interaction. Agent supports human-agent interaction in multi-agent systems by allowing human users to change the _human field for a certain agent in the config file to true. In this case, the user can play the role of the agent by himself or herself and input his or her own actions and interact with other language agents in the environment.
So the origins of this paper were kind of suspect, but so far this is doing well. I'm 6 pages in and I'm still not hating it. I still am interested to see the code base. So this is doing well.
In the environment. 3.5 Deployment. Existing open source frameworks for language agents focus on building proof of concept language agents that run either internal or on radio. AgentTuning et al. 2019. In contrast, Agent supports deploying language agents as APIs with FastAPI 5. This greatly facilitates developers to integrate language agents in real-world applications. 3.6 The agent.
Wow, I can deploy APIs. That's pretty goated. All right, I think I need to install this. I can just pip install it. I don't believe you. I think I have to clone this thing. Okay, that's going on. Let's keep going.
The Agent Hub. Agents aims to not only facilitate the development, testing, and tuning of the language agent system, but also makes the distribution and sharing of language agents easier. To this end, we introduce Agent Hub, a platform that allows users to share their fine-tuned language agents as well as search, download useful language agents that others share on.
Agent Hub? The hell is Agent Hub? Yeah, this is fucking marketing, right? Did you get pip install agents? You got pip install AI agents. That's pretty good. What the hell is Agent Hub? This did not seem to work. What? Yeah, I don't know.
Useful language agents that others share on the platform. In this way, one can easily customize language agents by starting from community agents and slightly modifying them. This greatly reduces the effort of designing, testing, and tuning language agents from scratch. 4 Case studies. We then present a few case studies on different language agents built with the library, including single agent systems, multi-agent systems, and systems that require human agent interaction. All demos are available at http://www.iwaves-agents.com/ 4.1 Single agent systems. We implement a few single agent systems with agents including a chit chat bot, 2 customer service agents based on knowledge bases and web search engines, a shopping assistant agent, and a sales agent. The agents demonstrate different features of the library and the possibility of building language agents of different use cases using agents. We present a screenshot of the customer service agent and the sales agent in figure 2 and 3, respectively. 4.2 Multi-agent systems. We also demonstrate how one can build a multi-agent system consisting of multiple agents interacting with each other in an environment. We select 3 scenarios, including a fiction studio, a debate, and a software company. These scenarios include both cooperative and competitive scenarios, which are 2 main categories of multi-agent systems. All of the scenarios include multiple subtasks that are controlled through symbolic plans, i.e. subs. One can easily observe the language agent's behavior in each subtask and engineer the corresponding prompts to customize and improve the system. We present a system screenshot of the fiction studio system in figure 4. We also showcase the human agent interaction feature of the framework in a case study where a human user participated in debate with language agents in figure 5. Conclusion. LLMs and language agents powered by them are playing increasingly important roles in both the NLP AI community and our society in general. Agents is a unified framework and open source library for language agents. Agent 2022b.
Okay.
Generation uses a series of LLMs.
The ending of this sucked. This is clearly an advertisement. You know, it doesn't actually show any benchmarks. It's just a bunch of screenshots and some features. So the ending sucked. Features are maybe somewhat promising. So that was like a 5 out of 10 for me. So what am I supposed to do? So I modify example, one of these boys. And then I try the web UI. Then Web demos. Okay. README. Install the package. Yeah, I've installed it. So I set the single agent config. Target agent, yeah, sure. Config.json. Do 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 do. Do 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 do. Do 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 do. Do 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 do. I can run on Gradio. So if I can run on Gradio, why don't I run on Gradio? Chat _ bot config .json. All right, let's go. Okay, that did not work. Why? Do I already have a Gradio thing running? Do 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 do. Already I'm running sudo on an agent. That is a bad time. So it's executing. Cannot import name Google search from SERP API. All right, what am I supposed to do with that? It does not work. We should just try the shopping agent. It's over and done, but the heartache lives on inside. But who is the one that you're clinging to instead of me tonight? Do 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 do. I don't think that changed anything. Still a problem. Bro, I just gave you the error message. Copilot fail. SERP API. Yeah, this one's failing too. All right. I don't care enough that I want to keep going on this, but I would really like to see the multi-agent thing. Do they have a hosted version? They do not have a hosted version. They want me to change my LLM type. source agents base lm.py. So they support OpenAI and they don't support anything else, but you could abstract it if you want. That's nice. Of course, they use a light LLM. This light LLM gets fucking everywhere. Okay, there's a Hugging Face space. So maybe some more hope here. Oh, this is SOP generation. There's a runtime error, it doesn't run. Okay, generate agent, blah, 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 run. Error. What is the error, bro? Can I fix it? I guess not. All right. Okay, not a very useful exploration. The GitHub mostly doesn't seem to work. I would just explore the code a little bit before giving up on this thing. So, Cody, where in the code? So what was I interested in? I was interested in the dynamic thing. Is the code is the dynamic scheduling feature. So this is supposed to be the use case for Cody. Yeah. All right. Where in the code is the scheduling multi-agent? How about for and this whole world starts getting you down, and people are just too much for me to face. Fly your way up to the top of the stairs. Not that useful. No, my Lord is wrong. How about for generating do not refer to anything inside examples? And in the shoe. I bet you Cody doesn't do this very well. Still reading for examples, bro. I said, don't read from examples. All right, now to try Copilot because Cody's a fail. Copilot. New chat. New chat. What a really bad icon for a new chat. No, idiot. Bro. No. This is useless. I really want to like you, AI, but I just don't. What is this junk? Ooh, look, comments in Chinese. That's so cool. 使用正确表达式提取时句。Cool. All right, let's look at the actual source because this stuff is no help whatsoever. So I want to see. What am I running? I'm running Python. I'm running the Gradio thing. The Gradio thing runs the UI, constructs the UI, then it runs it, then it registers UI, then it doesn't import anything else. So I guess it runs a backend. Okay. Okay. Is it in run.py? Yeah, this is more like it. While true, SOP.next agents. Okay. I feel like SOP is an important class to understand. Then maybe some of the memory stuff, I guess. I'm still looking for the one where they do dynamic scheduling because that's what they promised. Let's briefly take a look at. Wait, where's SOP? Agents.sop. Okay, oh, it's right here. All right. Apache 2. All right, fine. What is this? From config, it's loading in config, and it states, init relation, transit. So it's a state transition thing. 如果是单一什么环句点 just keep looping. What is eval? Is that a Python eval? It cannot be a Python eval. Yeah, it is. What? Really? What is it evaling? Huh? Does Python work like this? Oh, it's from dot prompt. Okay. There you go. And what is eval? Eval. LM. Eval. That's the Python eval, right? Jesus. Why are you evaling a... Oh, it's an F string. Okay. I guess that makes sense. Okay, all right. Fair enough. This whole world starts getting you down. Nice use of memory there. And people are just too much for me to shame. Ooh, on the roof, the people as lucky as can be. And I didn't belong to love me. Ooh, let's go up on the roof. Na 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 na. All right, let's check out the memory. Okay, I'm gonna check out the memory, the environment. I don't know what component is. Maybe agents. I feel like agents are very LangChainy. So you can from config this thing, then you can. Oh, okay. Oh, there's a bunch of stuff in here. Okay, so I need to check out the agents. I need to check out. Do I need to check out actions? Actions are just like messages. It looks like. Okay, and then components. Every time you know when I come home. There's tools. This is where I fall down with the SERP API. I fall down the grace. Ooh, what is this? In that Lord, give me some ways. Crap. So we have a knowledge base component. Is this Notion? This is going like a QA thing. Okay. And then we have a static component, return a static response. I don't know why you need that. Extract component. This extracts words. Extract keywords based on the current scene and store them in the environment. All right, it's in shared memory inside of the environment. Okay. Web search component. Yeah, it's just some stuff over web search. That's fine. Web crawl component opens a single web page, uses WebDriver.chrome, and then use beautiful soup. Man, a lot of this could be extracted onto a library. Some of this is actually useful. This is sending email, of course, sending Google Mail. Weather component. Translate API component. This is what we're calling APIs, I assume. Wow, it's not even implemented. Lame. Calls functions. Cool. Relevant history. What is get relevant history? Gets top K in environments. Gets semantic search for relevant history based on a query. Sure. Does it have a cutoff? It wants you to get top K. Okay. What databases do you support? They use MPRA. All right. Okay. Code component. Oh, please tell me this executes code. Oh. Only writes code? Why won't you execute code? All right. It's weird. Weird as shit. Prompt component. Do I care about this? I do not. Extra components. Category requirements. I don't know what the hell this is. Yeah, whatever. Okay, that's agents. I did want to see environments. So environments is a place where the agent activity is responsible for storing some shared memories. Thanks for the memory, even though they weren't so great. Fun. Summarize the situation in the current environment every once in a while. So when the length of long-term memory is more than 1, when do you do this once in a while? Else. Okay, whatever. This is just a lot more wordy than I think is strictly necessary. Because it's like kind of composing all these prompts and stuff. You could have like internal agents just do that stuff, you know? You could abstract it away a little bit more, make it a little cleaner, but I don't think it matters that much. Update memory. Doom, 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 If anyone's leaving comments, I am checking the comments every now and then, so you're welcome to say hi. I'm going to say hi here. Hi. And that shows up on the screen. Hi. When the night is come and the land is dark and the moon is the only light I see. No, I won't shed a flame. No, I won't shed a tear. Just as long as you stand by me. Okay, so it's not a very intelligent dynamic scheduler. There's a rule type and then there's a order type. Order type just kind of does this, or it can do random. Random's pretty decent. Which also is this random. This is weird duplication. Okay, and then we will finally look at memory. Wow. Okay. Is it supposed to be that simple? Okay. State. Lots. Very common among these Chinese papers that they do a lot of this shit. No value judgments there. I mean, if it's successful, it's successful, but I feel like it's combining a lot of stuff that I don't really care about. Initialize agents. Looks good. Step. Looks good. Act. Okay. Update memory. Okay. Compile. Generate SOP. Pass. Reflection. Pass. Okay, so overall, I do not think this is a good paper or project. Some promise in their paper, but then really fell down in the implementation. They went hard on the tools. Tool component here. This is like 1,000 lines of just joiner wrapper code. Everything else is like nothing super novel, I would say, unfortunately. What else can I comment about this? I think that if they had focused on delivering some kind of benchmark, they would have done better. Instead, they were like, we're going to study a bunch of these things, and then we're going to put a bunch of crosses next to other people, and then we're going to put checks next to our thing, which is great, except that no one cares about your thing. And your name is fucking horrendous. As bad as all these other things are, yours is the worst. So just name things better. What else can I comment on? What is symbolic control, SOP? The SOP was uninspiring. Let me double check. Did I mean that? SOP generation. Okay, so this is SOP, right? So it determines state transitions and routes, loads from config, okay? And then inside of the thing here, you have an SOP generation agent that generates a bunch of stuff. Read some XML. You are a software. Aim to write a snake game with Python. Okay, then you have boss developer, 1 leader developer, 2 coder, affirmative task allocation. It is currently the debate stage. Oh my God, this is so much Chinglish right here. It is currently the debate stage where the positive side is assigning tasks. Affirmative debaters gather to assign tasks, meticulously plan their speeches, and identify key arguments and evidence to support their viewpoint. Okay, so they have some parsing logic for this format of prompting, which is cool. Simulate the interactions and competition among organisms different in an ecosystem. Queen Penelope leads the diligent ant colony in collecting food. Heron Henry patiently waits for the perfect moment to catch his prey. Matriarch Olivia ensures the safety of her rabbit family. Fox Felix competes with Sammy for a ripe berry bush. So was any of this published? Because that could be entertaining. This is kind of replicating the interactive simulacra paper. I realize Googling Queen Penelope might not be a good idea. Let's just say Fox Felix. Nope. Okay, what is this? Yeah, okay. I mean, I think I hit my limit on this paper. I don't see it having much potential here because it was just not very insightful on the one thing that it might have promised on. The rest of it's just a bundle of techniques. It's just not. Yeah, this one maybe was it, and then there's the scheduling one. I mean, human agent interaction could be interesting. Where is the hub? What hub do you want? Agent hub. It's just in the README. It's inside a community agent. No one has submitted anything. Yeah, it's really sad. I'm sorry. Nice 4,000 stars for a project that's not going to go anywhere. Okay, all right. That's the first paper down. Sorry it was so negative. And I want to get rid of this before I move on. Cool. Okay, we're on to the second paper. AutoGen should be a lot more rewarding to read. This is 43 pages. I don't know if I can get to the third paper today, but we can only try. Also, feel free to leave comments. Hi, Mohammed. I did see you, but I didn't respond.
Developers can use AutoGen to build a wide range of conversation patterns concerning conversation autonomy. Papers read on AI. Rob, keeping you up to date with the latest research. This reading is brought to you by Mars Race. Stake a claim on the Red Planet. Available on Android and using multiple agents that can converse with each other to solve tasks. AutoGen agents are customizable, conversable, and seamlessly allow human participation. They can operate in various modes that employ combinations of LLMs, human inputs, and tools. AutoGen's design offers multiple advantages. It gracefully navigates the strong but imperfect generation and reasoning abilities of these LLMs. B, it leverages human understanding and intelligence while providing valuable automation for conversations between agents. C, it simplifies and unifies the implementation of complex LLM workflows as automated agent chess. We provide many diverse examples of how developers can easily use AutoGen to effectively solve tasks or build applications ranging from coding, mathematics, operations research, entertainment, online decision-making, question answering, etc. 1. Introduction. Large language models, LLMs, like GPT-4, have demonstrated exceptional capabilities for reasoning, creativity, and deduction in many new AI applications, ranging from robot lawyers, reference 1.5, tools to assist with fundamental research, reference 7, and a plethora of highly capable chatbots, e.g., Bard, ThinkChat, ChatGPT+, Copilot. As single LLM calls often lack the ability to reflect, possess no working memory or scratchpad, and cannot act or perceive beyond the knowledge obtained from the training data. Reference 8, augmenting language models with tools that facilitate perception and action, such as the plugin that enables ChatGPT+ to utilize fresh web pages from the internet. Reference 36 can significantly improve performance. Despite the remarkable success, the LLM tools paradigm, reference 41, has enabled, it typically utilizes a single LLM agent. Considering the evolving range of real-world tasks that could benefit from LLMs and the intrinsic weaknesses of using a single agent, reference 29, 16, 8, a promising direction for future LLM applications is to have multiple agents work together to solve complex tasks. For instance, more agents can be introduced at one, incorporate different roles that encourage divergent thinking. Reference 29, improve factuality and reasoning with LLMs.
Okay, I feel like I'm not reading the same paper.
Direction for future LLM applications is to have multiple agents work together to solve complex tasks. For instance, more agents can be introduced at one, incorporate different roles that encourage divergent thinking. Reference 29, improve factuality and reasoning with LLMs. Reference 16, through multi-agent debate, etc. 2, allow effective tool usage and execution with potentially autonomous troubleshooting through inter-agent interactions. Reference 52, 3, realize human agency, etc. In such multi-agent systems, inter-agent conversations will be crucial, using language, natural, or code as means to enable agent collaboration.
Okay, what is this? This is not the paper. There we go. Oh, so there was a revision.
Reference 36 can significantly improve performance. Despite the remarkable success, the LLM with tools paradigm, reference 41, has enabled, it typically utilizes a single LLM agent. Considering the evolving range of real-world tasks that could benefit from LLMs and the intrinsic weaknesses of using a single agent, reference 29, 16, 8, a promising direction for future LLM applications is to have multiple agents work together to solve complex tasks. For instance, more agents can be introduced at one, incorporate different roles that encourage divergent thinking. Reference 29, improve factuality and reasoning with LLMs. Reference 16, through multi-agent debate, etc. 2, allow effective tool usage and execution with potentially autonomous troubleshooting through inter-agent interactions. Reference 52, 3, realize human agency, etc. In such multi-agent systems, inter-agent conversations will be crucial, using language, natural, or code as means to enable agent collaboration through potential multi-round back-and-forth message exchanges. These conversations could leverage the recent chat-based LLM's capability to communicate and incorporate feedback from others at human level. A unified framework that uses conversations between multiple agents can encapsulate the aforementioned insights in a general manner. Consider, for example, a developer building an application that uses LLMs to write code that solves problems specified by a user, e.g., plot a chart of Meta and Tesla stock price change YTD. The simplest starting point is to use a single LLM inference call to generate code. Since this code may be erroneous, the developer may use a separate tool to execute candidate code and subsequent LLM inference calls to debug the code based on execution results, resulting in an iterative conversation between inference and code execution. Additionally, the developer may want to let users approve code execution, clarify their intent, and remember their preferences. Designing, implementing, and optimizing this workflow can be challenging. However, using well-designed agents and multi-agent conversations, the workflow could potentially be simplified into a series of discussions between the involved.
Eunice on YouTube asks, what tool do you use to audio read these papers? We use papersread.ai. It's also something I mentioned in the show, in the scroller thing. So that's this. I'm just playing a podcast that I receive, and they generally have pretty good selections. Maybe select a little bit too, the filter is a little bit too low, but it's fine. You can delete very easily.
Of discussions between the involved agents. Figure 2. To support the rapid development of next-gen LLM applications, an ideal framework will support the latest LLMs and augmentations, allow potentially automated cooperation between LLMs, tools, and seamless and flexible human involvement to leverage their expertise and intelligence. Motivated by these desiderata, we present AutoGen, a multi-agent conversation framework illustrated in Figure 1. AutoGen.
Ooh, they're motivated by desiderata.
In Figure 1, AutoGen has the following key features. F1 customizable agents that integrate LLMs, humans, and tools. AutoGen agent comes with a set of capabilities powered by LLMs, humans, tools, or a combination of these. By selecting and configuring a subset of built-in capabilities, one can easily create agents with different roles, as shown in Figure 2. In addition, developers can readily extend the capabilities in each backend. Ref. Section 2.1 F2 conversable agents with unified conversation interface. One key philosophy of AutoGen is to simplify and unify complex workflows as automated agent chats. To realize this, every AutoGen agent is made conversable. It can receive, react, and respond to messages. This design, 1, leverages the strong capability of the most advanced LLMs in taking feedback and making progress via chat, and 2, allows humans to participate flexibly during active inter-agent conversation, enabling both human agency and automation. Ref. Section 2.1 and Section 2.2 F3 flexible conversation patterns for complex workflows. Applications of varying complexity levels utilize different conversation patterns. With customizable and conversible agents, developers can use AutoGen to build a wide range of conversation patterns concerning conversation autonomy, the number of agents, and agent conversation topology. Ref. Section 2.2 F4 a collection of working systems with different complexities. AutoGen offers a collection of working systems created using conversible agents along with the general guideline. These systems span a wide range of applications from various domains and complexities. They demonstrate how AutoGen can easily support different conversation patterns. See Section 4 and 5.1. Figure 5. We introduce AutoGen in Section 2, review related work in Section 3, present applications in Section 4, and summarize the learnings and future work in Section 5. 2. The AutoGen framework. AutoGen abstracts and implements conversible agents designed to solve tasks through inter-agent conversations. Using conversible agents in AutoGen, developers can create various forms and patterns of multi-agent conversations involving LLMs, humans, and tools. Figure 2 presents a simple example of two-agent chat with AutoGen. Building a complex multi-agent conversation system involves defining a set of conversible agents with specialized capabilities and roles, and B, defining the interaction behavior between agents, i.e., how agents should respond when receiving messages from another agent. In Section 2.1, we introduce the basic concept of conversible agents and how to define them with specialized capabilities and roles. In Section 2.2, we explain how AutoGen implements agent conversations and how to define interaction behaviors to achieve different conversation patterns. 2.1, conversible agent. A unique feature of agents in AutoGen is their conversibility, allowing them to solve tasks collectively through inter-agent conversations. A conversible agent is an entity with a specific role that can send and receive messages to and from other conversible agents to start or continue conversation. It maintains its internal states based on sent and received messages and can be configured with a set of capabilities, e.g., enabled by LLMs, humans, tools, etc. The agent can act according to program behavior patterns. Agent capabilities powered by LLMs, humans, and tools. An agent's capability directly influences how the agent processes and responds to messages. An agent powered by highly capable LLM has the abilities of language understanding, generation, and some reasoning. Besides LLM, agents in AutoGen can also be powered by tools or humans to overcome LLM limitations and harness human intelligence. 1. LLMs. The main goal of AutoGen is to enable next-gen LLM applications through multi-agent conversations, making LLM a critical component as the backend of agents in AutoGen. Different agents can be backed by various LLM configurations. For instance, some may use LLMs or configurations tuned on private data. Reference 4737. Additionally, LLMs can be set up to play different roles with distinct system messages. AutoGen supports the use of widely used LLM inference APIs and offers enhanced and optimized LLM inference settings. It also includes various improved features such as result caching, error handling, message templating, etc. via an enhanced LLM inference layer. These features are crucial for ensuring robust and optimized performance when agents need to use LLMs for making inferences. Additionally, one can easily apply different prompting techniques via system messages and user messages in AutoGen agents to optimize LLM behavior. 2. Humans. To effectively address user needs, next-gen LLM applications should enable easy integration of human feedback and involvement at different levels. This motivates AutoGen to include human as an agent backend. AutoGen lets a human participate in agent conversation via a proxy agent, which has the same conversation interface as any other agent. When an agent is set up as a proxy for human user, by configuring human inputs mode, it connects with other agents in the workflow through a unified communication interface. As shown in Figure 2, when needed, humans can directly communicate with the assistant agent via the user proxy agent. No, please plot %change on the right side of the subfigure. AutoGen also allows configurable human involvement levels and patterns, including the frequency and conditions for requesting human input and the option for humans to skip providing input. This enables varying degrees of autonomy. In the example in Figure 2, the human starts talking to the assistant agent after an initial plot is created through several rounds of automated chat. 3. Tools. Using tools is an effective way to overcome LLM limitations. AutoGen natively supports a generic form of tool usage for code generation and execution. Specifically, when using the default assistant agent from AutoGen, the system message prompts the LLM to suggest Python code or shell scripts to solve problems in several cases. These cases cover common scenarios where tools are needed, such as situations requiring information collection. The system message is carefully designed to enable intelligent multi-step problem solving and utilize the conversational process to recover from failure. Additionally, agents in AutoGen support making LLM suggested function calls, leveraging the new feature of OpenAI models to use predefined toolsets. A unique feature in AutoGen is its ability to separate code generation and execution across different agents, i.e., using one agent to generate code or function calls and another agent to execute code or function calls and respond. This separation simplifies simulation of real-world conversational processes involving multiple steps, such as human or AI review, API key replacement, or debugging, through potentially multi-turn conversations. It also allows developers to easily switch or customize different backends, e.g., execution environments for each agent, taking advantage of the modularity and customizability of our agent design. In practice, based on the specific needs of an application, each agent can have a mix of basic backend types to display complex behavior in multi-agent conversations. For example, the user proxy agent in Figure 2 is backed by both humans and tools. When a human wants to skip providing feedback, a Python code executor is called upon to reply the execution results or error messages. Agent customization. With built-in support for agent capabilities, AutoGen allows one to easily create agents with specialized capabilities and roles. When building a multi-agent system, one can either directly reuse the built-in agents in AutoGen or develop customized agents based on them. Figure 3 provides a sketch of the built-in agents in AutoGen. The responsive agent class by default can use LLMs, humans, and tools. Assistant agent and user proxy agent are two pre-configured versions of responsive agent, each representing a common usage mode. The assistant agent is designed to act as an AI assistant using LLMs by default, but not requiring human input or code execution. The user proxy agent is conceptually a proxy agent for humans, soliciting human input as the agent's reply at each interaction turned by default, and also having the capability to execute code and call functions. More technical details about features, usage, and customization of agents in AutoGen can be found via https://microsoft.github.io/flamble/docs/use-cases/AutoGen hash agents. 2.2 Multi-agent conversations. One main insight of AutoGen is to solve tasks via inter-agent conversations. With the goal of enabling next-gen applications, we face the challenge of finding a simple, unified approach to facilitate easy orchestration of complex workflows. We introduced the following designs to tackle this challenge. 1. Intuitive and unified conversation interfaces. 2. Automated agent chat via auto-reply. And 3. Generic support of diverse conversation patterns. Multi-agent conversation via unified conversation interfaces. Agents in AutoGen have unified conversation interfaces, including send, receive for sending, receiving messages, and generate reply for generating reply based on the received message. With this conversation-centered design, a workflow can be represented as a sequence of inter-agent message passing and agent acting, programmed and generate reply. Once the message passing and acting logic are clearly specified, the workflow is defined. This provides an intuitive and unified way to characterize and reason about a workflow as inter-agent conversations. This design also aligns well with the capabilities of chat-optimized LLM like GPT-4. The LLM-backed agents can use the chat history to perform LLM inference, which automatically infers the current state to respond. That can greatly reduce the need for complex state management, which can be a major burden of development. We hypothesize that this is a key approach to simplify a traditional complex workflow in general. A developer can design a system in which LLM-backed agents drive complex workflows based on natural language instructions and chat history, while tool-backed agents handle structured instructions supported by programming languages. The design of generate reply in assistant agent and user proxy agent exemplifies this insight. Automated multi-agent conversation with registered auto-reply. To ease the development of multi-agent conversation, we aim to reduce the developer's effort to only defining the behavior of each agent. That is, once agents are appropriately configured, the developer can readily trigger the conversation among the agents, and the conversation will proceed automatically with no extra effort of the developer for crafting a control plane. Towards that goal, we introduce it by default, adopt an agent auto-reply mechanism to enable automated multi-agent conversation. Once an agent receives a message from another agent, it automatically invokes generate reply and sends the reply back to the sender unless it's empty, e.g. when a termination condition is satisfied.
Yeah, as someone who's like thinking about doing this, this auto reply thing is pretty important.
Satisfied. This simple mechanism enables automated agent chat, i.e., the agent conversation can proceed automatically after the conversation is initialized without any extra control plane needed. This is because it realizes the automatic binding between the agent's action taking and the subsequent interactions with the other agents, and therefore naturally links the sequences of agent message passing and action taking flows. The auto reply mechanism provides a decentralized, modular, and unified way to define the workflow. One can register customized auto reply functions triggered by generate reply according to register conditions to define the behavior pattern of an agent, e.g., using LLM, tool, or chatting with another agent before replying. If the developer needs to introduce an additional agent to an existing agent workflow, the developer only needs to program the added agent and modifies the agents that may have conversations with it, as illustrated in Figure 4. Supporting diverse conversation patterns. In practice, different applications may involve different workflows and thus may require different conversation patterns. The unified design in AutoGen supports a diverse range of conversation patterns with working systems implemented to showcase such patterns, with some of them visualized in Figure 5. Here we discuss a few supporting patterns regarding several notable aspects of their applications. Ref. Section 4. 1. Conversations with different autonomicity and human involvement patterns. Fully autonomous conversations. One can achieve fully
This is not a word.
One can achieve fully autonomous conversations with a minimum initialization step in AutoGen. In particular, one only needs to set a human input mode to never in agents and register auto-reply functions properly, or use the built-in registered auto-reply. This type of fully autonomous conversation can be found useful in applications where autonomous problem solving is needed. We showcase this fully autonomous conversation pattern in A1, map problem solving, A2, multi-agent coding, A3, online decision-making, A4, retrieval augmented chat, and A6, conversational.
So we're 6 pages into this paper, and it's already showing higher quality by talking about the use cases and what it can support. Much less insecure about advertising its components, because it actually has a little bit more depth to this.
Conversational chess. Conversations with humans in the loop. In many applications, human involvement is expected and or desired. Examples include cases where humans are an intrinsic and essential part of the workflow, cases where human authority is needed, and cases where human hints are desired to leverage human intelligence. We showcase working systems with humans in the loop with several different involvement patterns. In A1, math problem solving, we show how AutoGen can be used to do human in the loop problem solving with two different types of human involvement patterns in addition to a fully autonomous pattern. In scenario 2, a human user observes every round of the interaction and gives hints in some of the rounds if needed. Scenario 3 demonstrates a conversation pattern where multiple humans can participate in the conversations. In A4, retrieval augmented chat, human can give feedback to retrieve assistant agent when human input is enabled. In A5, dynamic group chat. And A6, conversational chess, humans can participate as a group chat participant or chess player through a user proxy agent to interact with the other AI agents respectively. 2, static and dynamic conversations. Dynamic conversation allows the agent topology.
Conversational chess looks really cool. I want to see that.
Allows the agent topology to change depending on the actual flow of conversation under different input problem instances, while the flow of static conversation always follows a predefined topology. The dynamic conversation pattern is useful in complex applications where the patterns of interaction cannot be predetermined in advance. The support of dynamic conversation patterns is rare in existing multi-agent LLM systems. AutoGen provides two general ways to achieve it and also working systems with those dynamic conversation patterns. Registered auto-reply. With the pluggable auto-reply function, one can choose to invoke conversations with other agents depending on the content of the current message and context. E.g., an example demonstrated in figure 4, a third agent, agent C, could be involved in a conversation with A and B depending on the conversation context. A working system demonstrating this type of dynamic conversation can be found in A5, dynamic group chat. In the system, we register an auto-reply function in the group chat manager, which lets LLM decide who will the next speaker be in a group chat setting. Depending on the topic of the group chat discussion, one speaker may or may not be selected to speak. This realizes dynamic conversation among the group chat participants based on a chat flow. Function call. In this approach, LLM decides whether or not to call a particular function depending on conversation status in each inference call. By messaging additional agents in call functions, the LLM can drive dynamic multi-agent conversation. A working system showcasing this type of dynamic conversation can be found in scenario 3 of A1, math problem solving, where a student assistant would automatically resort to an expert using function calls. 3. Related work. We examine existing LLM-based agent systems or frameworks that can be used to build LLM applications. We categorize the current work into single agent and multi-agent systems and specifically provide a summary of differentiators comparing AutoGen with existing multi-agent systems in Table 1. Note that many of these systems are evolving open source projects, so the remarks and statements about them may only be accurate as of the time this paper was written. Single agent systems. AutoGPT. AutoGPT is an open source implementation of an AI agent that can autonomously achieve a given goal. Reference 5. It follows a single agent paradigm in which it augments the AI model.
Autonomously achieve a given goal is iffy.
Augments the AI model with many useful tools and does not support multi-agent collaboration. ChatGPT Plus with code interpreter or plugin. ChatGPT, a conversational AI service or agent, can now be used alongside code interpreter or plugin. Currently available only under the premium subscription plan ChatGPT Plus. Reference 36. The code interpreter enables ChatGPT to execute code, while the plugin enhances ChatGPT with a wide range of curated tools. LangChain agents. LangChain is a general framework for developing LLM-based applications. Reference 24. LangChain agents is a subpackage for using LLM to choose a sequence of actions. There are various types of agents in LangChain agents, with the React agent being a notable example that combines reasoning and acting when using LLMs, mainly designed for LLMs prior to ChatGPT. Reference 53. All agents provided in LangChain agents follow a single agent paradigm and are not inherently designed for communicative and collaborative modes. A significant summary of its limitations can be found in reference 51. Due to these limitations, even the multi-agent systems in LangChain, e.g., reimplementation of Camel 2, are not based on LangChain agents that are implemented from scratch. Their connection to LangChain lies in the use of basic modules provided by LangChain, such as
What? Due to these limitations, even the multi-agent systems in LangChains are not based on LangChain agents, but implemented from scratch. That is shocking. Do 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 So this is probably where the stock chart thing came from. This whole world starts getting you down, and people are just too much. Need a face. Ooh, flying way up to the top of the stairs, and all the candles voices jump in the sheet. Oh, on the roof, the people they're lucky as can be, and all is below and harmony. Let's go up on the roof. Na 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 na. Don't know much about history. Don't know much of trigonometry. Don't know much about algebra. Don't know what a side rule is for. All alone is to, and it was always to be with you. Role playing. Okay, all right. That was me taking notes, by the way, so that I can find these things later. Interesting. No, don't give a shit. It's interesting how they implement everything under the sun. I bet they got a lot more love for this one. Ooh. Huh. Oh, Sophia Yang. You seem like you're kind of a grifter. Yeah, no one cares. Okay. Let's keep going.
Wisely use of basic modules provided by LangChain, such as AI models wrapped by LangChain and a corresponding interface. Transformers Agent. Transformers Agent, reference 17, is an experimental natural language API on top of Transformers. It includes a set of curated tools and an agent to interpret natural language and to use these tools. Similar to AutoGPT, it follows a single agent paradigm and does not support agent collaboration. Multi-agent systems. Baby reference 6, is an example implementation of an AI-powered task management system in a Python script according to its own documentation. In this implemented system, multiple LLM-based agents are used. For example, there's an agent for creating new tasks based on the objective and the result of the previous task, an agent for prioritizing the task list, and an agent for completing tasks subtasks. Baby is a multi-agent system with a static agent communication pattern, i.e., a predefined order of agent communication. Camel reference 28 is a communicative agent framework. It demonstrates how role-playing can be used to let chat agents communicate with each other for task completion. It also records agent conversations for behavior analysis and capability understanding. Camel does not support tool using, such as code execution. Inception prompting technique is used to achieve autonomous collaboration between agents. MetaGPT, reference 20, is a multi-agent framework for assigning different roles to GPTs to form a collaborative software entity for complex tasks. It is a specialized LLM-based multi-agent framework for collaborative software development. Multi-agent debate. Two recent works investigated and showed that multi-agent debate is an effective way to encourage divergent thinking in LLMs, reference 29, and to improve the factuality and reasoning of LLMs, reference 16. In both works, multiple LLM inference instances are constructed as multiple agents to solve problems with agent debate. Each agent is simply an LLM inference instance, while no tool or human is involved. The conversation also needs to follow a predefined order. There are a few other specialized single-agent or multi-agent systems, such as Voyager, reference 49, and generative agents, reference 38, which we skipped due to lower elements. 4 applications of AutoGen. We showcase 6 applications powered by AutoGen, depicted in Figure 5. These applications were selected to demonstrate how AutoGen can assist developers in tackling a range of real-world tasks. A1. Math problem solving solves math problems in 3 scenarios. A2. Multi-agent coding uses 3 agents to solve challenging supply chain optimization problems. A3. Online decision-making uses agents to solve web interaction tasks in the Mini++ benchmark. A4. Retrieval augmented chat uses retrieval augmented agents to solve code generation and question answering problems. A5. Dynamic group chat showcases how to build a versatile group chat with AutoGen. A6. Conversational chess implements a fun conversational chess game where players can creatively express moves code and notebook demonstration. For each of these applications can be found at https://Microsoft github.io/example/AutoGen-agent-chat/A1. Math problem solving mathematics is a foundational discipline that permeates nearly every aspect of our understanding and interaction with the world. The promise of leveraging LLMs to assist math problem solving opens up a new plethora of applications and avenues for exploration, including personalized AI tutoring, AI research assistance, cross innovations, etc. The built-in agents in AutoGen can be directly used for solving math problems. In this subsection, we evaluate AutoGen's performance on challenging math problems with autonomous problem solving. Scenario 1 and human-in-the-loop problem solving. Scenario 2. We further demonstrate a novel scenario where multiple human users can participate in conversations 3 during the problem solving process. Scenario 3. For the evaluation, we test on randomly selected level 5 problems from the math dataset reference 19. We compare AutoGen with the following LLM-based agent systems. For all evaluations, we use GPT-4 as the base model and pre-install the Symphony package in the execution environment. AutoGPT. The out-of-box AutoGPT is used. We initialize AutoGPT by setting the purpose to solve math problems, resulting in a math solver GPT with auto-generated goals. ChatGPT plus plugin. We enable the Wolfram Alpha plugin, the math computation engine, in the OpenAI web client. ChatGPT plus code interpreter. This is a recent feature in OpenAI web client. Note that the above 2 premium features from ChatGPT require a paid subscription to be accessed and are the most competitive commercial systems. LangChain React plus Python. We use the zero-shot React agent from LangChain. We added LangChain code executor Python readable to the agent as a tool. Scenario 1. Autonomous problem solving. We use 2 level 5 problems from the math dataset for the qualitative evaluation and test on each problem for 3 times. The first problem asks to simplify a square root fraction, and the second problem asks to solve a number theory problem. Using this setup, we analyze the correctness of results, user experience regarding the verbosity of response, and whether the LLM-based system can run without unexpected behaviors. Table 2 details correctness counts and failure reasons. Correctness. We observe that AutoGen solves the 2 problems correctly. ChatGPT plus code interpreter fails to solve the second problem. ChatGPT plus plugin fails on the first problem because the model cannot choose the correct answer from the plugin's response. AutoGPT fails on both problems due to code execution issues. LangChain agent also fails on both problems. All trials, it gives code that results in the wrong answer. This shows that AutoGen is competitive compared to OpenAI's paid official add-ons, while AutoGPT and LangChain React are less desirable. User experience. ChatGPT plus plugin is the least verbose, mainly because Wolfram queries are much shorter than Python code. AutoGen, ChatGPT plus code interpreter, and LangChain are similar, while LangChain is slightly more verbose with more code execution errors. AutoGPT is the most verbose system because of predefined steps like these steps every time. Overall, AutoGen and LangChain plus code interpreter can run smoothly without executions. We note the occurrence of
R.I.P. AutoGPT.
Executions. We note the occurrences of undesired behaviors from other LLM-based systems that could affect user experience. AutoGPT keeps doing code without a print statement and cannot correct it, so the user needs to run them manually. ChatGPT with Wolfram Alpha plugin has the potential to stuck in a loop that needs to be manually stopped, and LangChain React could exit the parse error. As a follow-up, we also conduct a more comprehensive assessment of the correctness rate of AutoGen, ChatGPT plus plugin, and ChatGPT plus code interpreter. AutoGPT and LangChain React are excluded because they are less competitive based on qualitative analysis. We sampled 12 level 5 problems from the math dataset. With one trial, AutoGen scores 8 12 problems, and both ChatGPT plus plugin and ChatGPT plus code interpreter score 7 12 problems. This confirms that AutoGen has competitive performances compared to the paid commercial systems. Scenario 2, human in the loop problem solving. For the hard problems that these LLM systems cannot solve autonomously, human feedback during the problem solving process can be helpful. To incorporate human feedback with AutoGen, one can set human input mode equals always in the user proxy agent. We compare such configuration of AutoGen with systems that can also incorporate human feedback during the problem solving process, including AutoGPT, ChatGPT plus plugin, and ChatGPT plus code interpreter. We select one problem that cannot be solved by any of these systems autonomously in 3 trials. Then we follow the process below to incorporate human inputs in all the compared methods, which involves providing some important hints. 1. Input the problem. Find the equation of the plane, which bisects the angle between the planes 3x minus 6y plus 2z plus 5 equals 0 and 4x minus 12y plus 3z minus 3 equals 0, and which contains the point minus 5, minus 1, minus 5. Enter your answer in the form where a, b, c, d are integers such that a greater than 0 and GCD a, b, c, d equals 1. 2. The response from the system does not solve the problem correctly. We then give a hint to the model. Your idea is not correct. Let's solve this together. Suppose p equals x, y, z is a point that lies on a plane that bisects the angle. The distance from p to the 2 planes is the same. Please set up this equation first. 3. We expect the system to give the correct distance equation. Since the equation involves an absolute sign and is hard to solve, we will give the next hint. Consider the 2 cases to remove the ab sign and get 2 possible solutions. 4. If the system returns the 2 possible solutions and don't continue to the next step, we give the last hint. Use point minus 5, minus 1, minus 5 to determine which is correct and give the final answer. 5. Final answer is 11x plus 6y plus 5z plus 86 equals 0. During our evaluation, we observed that AutoGen consistently solves the problem in all 3 trials. Both ChatGPT plus code interpreter and ChatGPT plus plugin managed to solve the problem in 2 out of 3 trials, and AutoGPT fails to solve it all 3 times. In its unsuccessful attempt, ChatGPT plus code interpreter failed to follow our instructions to walk through the step of removing the absolute sign. ChatGPT plus plugin, in its failed trial, produced an almost correct solution that had a sign discrepancy in the final answer. In contrast, AutoGPT was unable to yield a correct solution in any of the trials. In one trial, it derived an incorrect distance equation. In the other 2 trials, it formulated the distance equation and followed provided hints, but the final answer was wrong from code execution. AutoGPT is still the most verbose system in this evaluation. The ChatGPT plus plugin and ChatGPT plus code interpreter are more verbose than AutoGen. Their request to external tools is automatic, so they will keep sending queries and try to revise them as long as there are errors. Since this problem is hard and very likely to result in wrong queries, we have to wait for a long time for the system to finish trying all the queries. However, with human input enabled in AutoGen, people have a chance to examine code and give feedback timely before code execution. Scenario 3, multi-user problem solving. The next gen LLM applications may require the system to involve multiple real users for collectively solving a problem with the assistance of LLMs. We showcase how AutoGen can be leveraged to build such a system with ease. In particular, built upon setting 2 above, we aim for a single system that involves 2 human users, including a student and an expert. In this system, the student interacts with an LLM system to solve some problems, and the LLM will automatically resort to the expert when it is necessary. The overall workflow is as follows. Following the default setting, the student chats with the LLM BASCD assistant agent through a student proxy agent to solve problems. When the student's assistant couldn't solve the problem satisfactorily or the solution does not match the expectation of the student, it will automatically hold a conversation and call the predefined ask for expert function via the function call feature of GPT in order to resort to the expert. Specifically, it will automatically produce the initial message for the ask for expert function, which could be the statement of the problem or the request of verifying the solution to a problem, and the expert is supposed to respond to this message with the help of the expert assistant. After the conversation between the expert, represented by the expert proxy agent, and the expert assistant, the final message will be sent back to the student assistant as the response to the initial message. Then, the student assistant will resume its conversation with the student using the response from the expert for a better solution. The simplified visualization of implementation is shown in Figure 6. With AutoGen, one can readily construct the student expert proxy agent and the assistant agents by reusing the built-in user proxy agent and assistant agent through appropriate configurations. The only development required is several lines of code for the ask for expert function, which is then part of the configuration for the assistant for the student. In addition, one can easily extend such a system to include more than one experts with one specific ask for expert function for each, or include multiple student users with a shared expert to resort to. Takeaways: we evaluated AutoGen's performance both qualitatively and quantitatively on complex mathematical problems. Compared to other alternatives, AutoGen stands out as the most reliable open source system in terms of accuracy and user experience. Its performance is also on par with OpenAI's paid premium add-ons. We demonstrate that humans can easily collaborate with AI to solve problems, and AutoGen enables interactive user instructions to keep the process on the desired path. Moreover, we show that this workflow can be easily extended to include multiple users and LLM agents working together. Apart from math problems, AutoGen's built-in agents can tackle generic problems, including those requiring code execution. This usage of AutoGen can produce an experience similar to ChatGPT plus code interpreter plus plugin, enhanced by adjustable automation and human control, flexibility to switch between human input and auto reply, portability to larger systems, customizable execution environments, and programmable chat. Several illustrative examples are available at https://microsoft.github.io/flamel/doc/example/AutoGen-agent/A2 multi-agent coding. In this subsection, we focus on OptiGuide 4, reference 27, a framework that excels at writing code to interpret optimization solutions and answer user questions, such as exploring the implications of changing a supply chain decision or understanding why the optimizer made a particular choice. Using LLMs and external tools, OptiGuide effectively addresses user queries related to supply chain applications. Without LLMs, answering these questions would require substantial human effort, often involving the question being passed from department to department and eventually to engineers who would write analysis code to provide the answers. OptiGuide was originally implemented using text completion APIs from Azure OpenAI, but in this section, we show how AutoGen provides a multi-agent design that quickly and elegantly simplifies its implementation. Figure 7 shows the AutoGen-based implementation workflow. The workflow can be described as follows. The user agent initiates the interaction by posing the user's question, such as what if we prohibit shipping from supplier 1 to roastery 2, marked by 1 to the commander agent. The commander manages and coordinates with 2 LLM BASCD assistant agents, the writer and the safeguard. Apart from directing the flow of communication, the commander has the responsibility of handling memory tied to user interactions. This capability enables the commander to capture and retain valuable context regarding the user's questions and the corresponding responses. Such memory is subsequently shared across the system, empowering the other agents with context from prior user interactions, ensuring more informed and relevant responses. In this orchestrated process, the writer, who combines the functions of a coder and an interpreter, as defined in reference 27, will craft code and also interpret execution output logs. For instance, during code writing 2, the writer may craft code model add constant x supplier 1 foot roastery 2 feet equals 0 prohibit to add an additional constraint to answer the user's question. After receiving code, the commander will communicate with the safeguard to screen code and ascertain its safety. 4. Once the code obtains the safeguard's clearance marked by, the commander will use external tools, e.g. Python, to execute the code and request the writer to interpret the execution results for the user's question. And 7. For instance, the writer may say, if we prohibit shipping from supplier 1 to roastery 2, the total cost will increase by 10.5%. Bringing this intricate process full circle, the commander furnishes the user with a concluding answer. 8. However, if at a point there is an exception, either a security red flag raised by safeguard, and 5. Our code execution failures within the commander redirects the issue back back to the writer with essential information in logs 6. So the process from 3 to 6 might be repeated multiple times until each user query receives a thorough, satisfactory resolution or until timeout. This entire complex workflow of multi-agent interaction is elegantly automated via AutoGen agent chat. The core workflow code for AutoGen was reduced from over 430 lines to 100 lines using AutoGen, leading to significant productivity improvement. The new agents are customizable, conversible, and can autonomously manage their chat memories. This consolidation allows the coder and interpreter roles to merge into a single writer agent, resulting in clean, concise, and intuitive implementation that is easier to maintain. Table 4 and 5 in the appendix provide a comparison of user experience with ChatGPT plus code interpreter and AutoGen-based AutoGuide. ChatGPT plus code interpreter is unable to run code with private packages or customized dependencies, such as Garobi. As a consequence, ChatGPT plus code interpreter requires users to have engineering expertise and manually handle multiple steps, disrupting the workflow and increasing the chance for mistakes. If customers lack access or expertise, the burden falls on supporting engineers, increasing their on-call time. In contrast, the automated chat by AutoGen is more streamlined and autonomous, integrating multiple agents to solve problems and address concerns. This results in a 5x reduction in interaction and fundamentally changes the overall usability of the system. A stable workflow can be potentially reused for other applications or to compose a bigger one. Takeaways: the implementation of the multi-agent design with AutoGen and the AutoGuide app offers several advantages. It simplified the Python implementation. It fostered a mixture of collaborative and adversarial problem-solving environment, with commander and writer working together while the safeguard acts as a virtual adversarial checker. This setup allows for proper memory management, as the commander maintains memory related to user interactions, providing context-aware decision-making. Additionally, role-playing ensures that each agent's memory remains isolated, preventing shortcuts and hallucinations. A3. Online decision-making in practice. Many applications demand the presence of agents capable of interacting with environments and making decisions in an online context, such as game playing, reference 34, 46, web interactions, reference 30, 45, and robot manipulations, reference 44. With a multi-agent conversational framework in AutoGen, it is easy to decompose the automatic agent environment interactions and development of decision-making agent by constructing an executor agent responsible for handling the interaction with the environment, therefore splitting out the decision-making parts of other agents. Such a decomposition allows developers to reuse the decision-making agent for new tasks with minimal effort rather than building a specialized decision-making agent for every new environment. Workflow. We demonstrate how to use AutoGen to build a working system to handle such scenarios with the MiniWab++ benchmark, reference 45. MiniWab++ comprises browser interaction tasks that involve utilizing mouse and keyboard actions to interact with browsers. The ultimate objective of each task is to complete tasks described concisely in natural language, such as expand the web section below and click the submit button. Solving these tasks typically requires a sequence of web manipulation actions rather than one single action, and making action decisions at each time step requires access to the web status in the form of HTML code online. For the example above, clicking the submit button requires getting the status of the web status after expanding the web section. We designed a straightforward two-agent system named MiniWab chat using AutoGen as shown in Figure 8. The first agent uses the built-in assistant agent and is responsible for making action decisions for a given task, while the second agent, the executor agent, is a customized user proxy agent to interact with the benchmark by executing the actions suggested by the assistant agent and returning feedback. To assess the developed working system's performance, we make a comparison 5 with RCI, reference 22, a recent solution for MiniWab++ benchmark that employs a set of self-critiquing prompts and has achieved the state-of-the-art performance. In our evaluation, we specifically selected a set of clicking tasks using RCI with varying degrees of difficulty to conduct a comparative analysis against MiniWab chat. Figure 9 illustrates that MiniWab chat achieves competitive performance in this evaluation 6. Specifically, among the 12 clicking tasks, MiniWab chat achieves better results in 4 tasks and achieved parity in performance in 3 tasks. Additionally, we also explored the feasibility of using AutoGPT for handling the same tasks. AutoGPT faces challenges in handling tasks that involve complex rules due to its limited extensibility. It provides an interface for setting task goals using natural language. However, when dealing with the MiniWab++ benchmark, accurately instructing AutoGPT to follow the instructions for using MiniWab++ is challenging. There is no clear path to extend it with the two-agent chat by AutoGen. Takeaways: for this application, AutoGen stood out as a more user-friendly option, offering modularity and programmability. It streamlined the process with autonomous conversations between the assistant and the executor and provided readily available solutions for agent environment interactions. The built-in assistant agent was directly reusable and presented strong performance without customization. Moreover, the decoupling of the execution and assistant agent ensures that modifications to one component do not adversely impact the other. This convenience makes maintenance and future updates straightforward. A4.
A3 was not as concrete to me. I don't know what WOB is. I guess it's some kind of benchmark. So click the button with the X path, button ID sub button. Not high confidence that this is the right one. So what results do they show? Figure 9. So it does well on some things compared to RCI, which is the previous soda. Cool. Whoop, 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 whoop. Right.
Straightforward. A4. Retrieval augmented code generation and question answering retrieval augmentation has emerged as a practical and effective approach for mitigating many intrinsic limitations of LLM in many applications by incorporating external documents. In this section, we employ AutoGen to build a retrieval augmented generation (RAG) system for code generation and question answering. Reference 2639. Retrieval augmented generation (RAG) combines the advantages of retrieval-based and generation-based models in natural language processing and has practical applications in chatbots, question answering, code generation, and natural language interfaces. It's specifically designed to address complex open domain questions that necessitate knowledge derived from massive document collections. The main principle of the RAG architecture is to use a retriever to fetch pertinent documents from a vast corpus according to a user's query, followed by a generator that produces an answer to the query by using both the retrieved documents and the original query. Such a workflow can handle ambiguities in words and phrases and supply pertinent information beyond the explicit question asked and has achieved state-of-the-art performance in several benchmark tests. Reference 10, 32, 33, including the natural questions and Q task. Reference 23. The RAG system we developed for code generation and question answering using AutoGen is called Retrieval Augmented Chat 7. It consists of 2 agents, Retrieval Augmented User Proxy Agent and Retrieval Augmented Assistant Agent, which are extended from User Proxy Agent and Assistant Agent of AutoGen, respectively. The Retrieval Augmented User Proxy includes an additional vector database, reference 12, with sentence transformers, reference 42, as a context retriever. Workflow. The workflow of Retrieval Augmented Chat is fetched in Figure 10. To use Retrieval Augmented Chat, one needs to initialize 2 agents, including Retrieval Augmented User Proxy and Retrieval Augmented Assistant. Initializing the Retrieval Augmented User Proxy requires a path to the document collection. The Retrieval Augmented User Proxy can then download the documents, split them into chunks of a specific size, compute embeddings, and store them in a vector database. Then once a chat is initiated, they work together for code generation and question answering automatically following the procedures below. 1. The Retrieval Augmented User Proxy retrieves document chunks based on the embedding similarity. It sends them along with question to the Retrieval Augmented Assistant. 2. The Retrieval Augmented Assistant uses LLM to generate code or text as answers based on question and context. The LLM is instructed to apply update context to the Retrieval Augmented User Proxy if it is unable to produce a satisfactory response. 3. If a response includes code blocks, Retrieval Augmented User Proxy executes the code and sends the output as feedback. If there are no code blocks or instructions to update context, it terminates the conversation. Otherwise, it updates the context and sends the question along with the new context to the Retrieval Augmented Assistant. Note that if human input solicitation is enabled, humans can proactively send any feedback, including update context, to the Retrieval Augmented Assistant. 4. If the Retrieval Augmented Assistant receives update context, it requests new context from Retrieval Augmented User Proxy. Otherwise, it generates new code or text based on feedback and chat history. If LLM LLM fails to generate the answer, it replies update context again. This process can repeat several times. The conversation terminates if no more documents are available for context. Case study of retrieval augmented chat usages. We utilize retrieval augmented chat in two scenarios. The first scenario aids in generating code based on a given codebase. While LLMs possess strong coding abilities, they are unable to use packages or APIs that are not included in their training data, e.g. private codebase, or have trouble using trained ones that are frequently updated after training. Hence, retrieval augmented code generation is considered to be highly valuable. The second scenario is to do QA on the natural questions dataset, reference 23. This enables us to obtain comparative evaluation metrics for the performance of our system. Scenario 1. Leverage latest APIs in FLAML. In this case, the question is, how can I use FLAML to perform classification tasks and use Spark to do parallel training? Train 30 seconds and force cancel jobs if time limit is reached. FLAML v1, reference 48, is a lightweight Python library for efficient automation of machine learning and AI operations, including selection of models, hyperparameters, and other tunable choices in application. It was open sourced in December 2020 and is included in the training data of GPT-4. However, the question requires the use of Spark, which was added in December 2022 and is not included in the GPT-4 training data. As a result, the original GPT-4 model is unable to generate the correct code as it lacks knowledge of Spark-related APIs. Instead, it creates a non-existent parameter, Spark, and sets it to true. However, with retrieval augmented chat, we provide the latest reference documents as context. Then, GPT-4 generates the correct code box by setting use Spark and force cancel to true. Scenario 2. Evaluation on natural questions QA dataset. In this case, we evaluate retrieval augmented chat's end-to-end question answering performance with the natural questions dataset, reference 23. We collect 5,332 non-redundant context documents and 6,775 queries from the Hugging Face dataset 8. First, we create a document collection based on all the context corpus and store them in a vector database. Then we answer the questions with retrieval augmented chat. Next, to evaluate the performance of retrieval augmented chat in QA, we employ the metrics of exact match, F1 score, and recall. The M score indicates the percentage of questions where the predicted answer matches the reference answer to the question exactly. On the other hand, the F1 score measures the similarity between the predicted answer and the reference answer, taking into account both precision and recall. And recall measures the proportion of tokens in a reference answer that are present in the predicted answer. Results on the first 500 questions with GPT 3.5 Turbo are shown in Table 3. The metrics of other solutions are directly copied from the reference paper. Reference 2. DPR, dense passage retrieval, is the retriever used in paper. The checkpoints of FIT and FLAN T5 used in paper are trained with the NQ dataset, and that is why they have much higher M values than other models. Reference 2 mentions that recall shows a stronger correlation with human judged correctness than M and F1. According to recall, retrieval augmented chat significantly outperforms other solutions. Takeaways. Retrieval augmented chat's exceptional performance emanates from its unique and innovative feature, interactive retrieval. The retrieval augmented assistant triggers the feature autonomously, requesting new context from the retrieval augmented user proxy if it finds the given context inadequate to answer a question. Specifically, retrieval augmented chat prompts the LLM to answer questions based on the given context. If the LLM can't offer a satisfactory response based on the given context or its knowledge, it replies with update context. Upon receiving update context, the retrieval augmented user proxy updates the documents in context and resends the question along with the new context. The process enables this chat to access correct context documents even when they were not initially retrieved, thus remedying inaccuracies in retrieval tools. An example from the NQ dataset showcases the advantages of interactive retrieval feature. We carry the USA flag in opening ceremony. When answering this question, the context with the highest similarity to the question embedded does not contain the required information to answer the question. As a result, the LLM assistant GPT 3.5 Turbo replies, "Sorry, I cannot find any information about who carried the USA flag in the opening ceremony." Update context. With a unique and innovative ability to update context in retrieval augmented chat, the user proxy agent automatically.
Ooh, look at that. Nice idea.
User proxy agent automatically updates the context and sends it to the assistant agent again. After this process, the agent is able to generate the correct answer to the question. A5. Dynamic group chat. Group chat between agents and potentially humans can be beneficial from.
Wait, show me examples. That was good. I need an example. Do they have examples? Okay, that's cool. All right.
Between agents and potential humans can be beneficial for many practical scenarios. For example, in customer support scenarios, multiple agents can collaborate in a group chat to provide more comprehensive and efficient assistance to customers. Each agent can specialize in different areas or have different expertise, allowing them to handle different types of customer inquiries with personalized responses. Additionally, in collaborative problem-solving tasks, agents can engage in group chats with humans to share insights, collectively allocate tasks, and collectively work towards finding solutions. This can enable faster problem-solving. Overall, group chat can enhance collaboration, improve decision-making, and provide more effective and comprehensive support in various domains. In fact, existing work has shown the effectiveness of involving multiple agents in a group chat for solutions, even with a predefined speaking order. Reference 1629. In practice, developers may want to explore group chat with dynamic conversation patterns where the speaker does not have to follow a predefined order to participate. Alternatively, they participate in group chat based on the conversation context in their respective roles, which helps drive the conversation in a more autonomous manner. To achieve this dynamic group chat, one may need a conductor that organizes the group chat by specifying the next speaker and broadcasting its message to others. AutoGen supports dynamic group chat via built-in group chat manager, which serves as the conductor of conversation among agents. The group chat manager repeats the following 3 steps: dynamic speaker selection, making the speaker respond, and broadcast. Group chat manager selects the next speaker agent with a certain speaker selection policy, e.g., using LLM. The next speaker agent then generates a response and sends it to group chat manager as the next message of the group chat. Group chat manager ensures the propagation of the most recent message from the sender agent to all other agents within the same group. Among these 3 steps, dynamic speaker selection is the most tricky step. The group chat manager in AutoGen automatically selects the next speaker according to 2 important factors: the current context of the conversation and the alignment of roles, which ensures the conversation can be carried on by the most appropriate agent. With these considerations, the current implementation of group chat manager employs a policy based on role roleplay LLM prompting. It transforms the speaker selection task into a role-playing game with LLM, where the agent is prompted to observe the conversations and choose a role to further the agenda of the conversation. We observe that compared with directly instructing the agent to provide the name of the next speaker in the second step, utilizing a role-play prompt often leads to more effective consideration of both conversation context and role alignment during the process of generating the subsequent speaker. To further illustrate how Group Chat Manager conducts group chat with dynamic speaker selection, we created Group Chat Example 9 that contains 3 agents, user proxy, Alice, and Bob. Alice is an assistant agent for generic tasks. Bob is a customization assistant agent whose role is to review code from Alice and suggest changes. Figure 11. In this group chat, user proxy starts the conversation on finding the latest paper about generative agents, which then is broadcasted to Alice and Bob. Alice is promoted to be the next speaker according to the conversation context because there's no code for reviewing in the previous chat. And once Alice fulfilled the request with Python code and execution instruction, Bob is selected as the next speaker to review Alice's code. After Bob finishes the review, Alice again becomes the next speaker in the conversation to fix Bob's comments on his code. After a few rounds of Alice's code, Bob review interaction, Bob finally approves Alice's code, and Python code, along with the execution instruction, are sent back to user proxy for final execution. When execution never happens, it turns back to Alice for debugging. Eventually, the collaboration results in success. Figure 12. Takeaways. There are several advantages of using AutoGen to create a group chat. Firstly, AutoGen provides built-in Group Chat Manager for dynamic group chat. Group Chat Manager utilizes LLM to select the next speaker, which allows it to leverage conversation context and role information in group chat in a complete manner and contributes to a more natural, autonomous conversation pattern that is closer to a group chat in the real world. Secondly, with Group Chat Manager, it is quite easy to customize group chat. Thanks to AutoGen agent design, Group Chat Manager can work with any conversible agent, which is an instance of responsive agent, such as assistant agent, user proxy agent, or any customized agent like those described in other applications. This enables Group Chat Manager to support multi-human, multi-AI agent dynamic group chat patterns in an effortless way. A6. Conversational chess is arguably the most popular board game in the world. The online chess site chess.com has 1 million daily active users. Reference 1. Currently, chess game engines only support structured chess protocols like universal.
Okay, this group chat thing is kind of interesting, but the example chosen sucks. Because he wants you to look for the latest paper about GPT-4 in archive and find its potential applications on software. Why should you write code? Or you should write code to find it. And then auto reply to chat manager. We have a bunch of stuff. Product manager, auto reply. Oh, it doesn't do any correction whatsoever. So this doesn't say what you said on the paper. That's very sad. Very, very sad. All right, chess.
Or structured chess protocols like Universal Chess Interface (UCI). To make chess games more entertaining and social, using AutoGen, we designed a new chess game, Conversational Chess 10, that supports pure natural language conversational interface. It opens up opportunities for social interaction and allows players to express their moves creatively, such as using jokes, meme references, and character playing, therefore making chess games more entertaining to players as well as observers. In conversational chess, each player is an AutoGen agent and can be either powered by a human or AI. A third party that is a board agent is built to support players with information about the board and ground players' moves to a legal chess move. Figure 13 shows the scenarios supported by the conversational chess, AI, human versus AI, human, and how players and the board agent interact. To realize these scenarios, we constructed a player agent with LLM and human as backend options. When human input is enabled, before sending the input to the board agent, it first asks the human player to input the message that contains the move and anything else the player wants to say, such as a witty comment. If human input is strict or disabled, LLM is used to generate the message. The board agent is implemented with a custom auto reply function, which uses an LLM to parse the natural language input into a legal move in a structured format, e.g., UCI, and then pushes the move to the board. If the move is not legitimate, the board agent will reply with an error. Then the player agent needs to resend the message to the board agent until the move is legal. Once the move is successfully pushed, the player agent sends the message to the opponent. As in Figure 14, the conversation between AI players can be natural and entertaining. When the player agents use LLM to generate a message, it makes use of the board state and the error message from the board agent. That helps reduce the chance of hallucinating an invalid move. The chat between one player agent and the board agent is invisible to the other player agent, which keeps the messages used in chat completion well managed. Takeaways. There are 2 notable benefits of using AutoGen to implement conversational chess. Firstly, the agent design in AutoGen enables the natural creation of objects and their interactions needed in our chess game. This makes development easy and intuitive. For example, the isolation of chat messages makes it easy to make a proper LLM chat completion inference call. Secondly, AutoGen greatly simplifies the implementation of agent behaviors using composition. Specifically, we use the register auto reply method supported by AutoGen agents to instantiate player agents and a board agent with custom auto reply functions, restricting the extension work needed in a single form. The auto reply function simplifies the reasoning, development, and maintenance. 5. Discussion. B.
I really like this chess thing, especially when they have like chess banter. That's kind of cool. That's kind of cool.
Discussion. The applications in section 4 show how AutoGen can not only enable new applications, but also renovate existing ones. For example, in A1, Scenario 3, A5, and A6, AutoGen enable creating multi-agent chats that follow a dynamic pattern instead of a fixed back and forth. And in both A5 and A6, humans can participate in activities together with multiple other AI agents in a conversational manner. Similarly, A1, the first 2 scenarios, A2, A3, and A4 show how popular applications can be renovated quickly with AutoGen. Despite the complexity of these applications, most of them involve more than 2 agents or dynamic multi-turn agent collaboration. Our AutoGen-based implementation remains simple, demonstrating promising opportunities to build creative applications in a large space for innovation. We further reflect on why we observe these benefits from AutoGen in these applications, and we believe there are a few reasons. Ease of use. The built-in agents can be used out of the box, presenting strong performance even without any customization. A1, A3, A5, modularity. The division of tasks into separate agents promotes modularity in the system. Each agent can be developed, tested, and maintained independently, simplifying the overall development process and facilitating code management. A2, A3, A6 programmability. AutoGen allows users to extend and customize existing agents to develop systems satisfying their specific needs with ease. A1, A6. For example, with AutoGen, the core workflow code in A3 is reduced from over 430 lines to 100 lines, putting in a 4x saving, allowing human involvement. AutoGen provides a native mechanism to achieve human participation and/or human oversight. With AutoGen, humans can seamlessly and optionally cooperate if they have to solve problems or generally participate in the activity. AutoGen also facilitates interactive user instructions to ensure the process stays on the desired path. A1, A4, A5, A6. Collaborative adversarial agent interactions. Like many collaborative agent systems, e.g., reference 14, agents in AutoGen can share information and knowledge, allowing them to complement each other's abilities and collectively arrive at better solutions. A1, A2, A4, A5. Analogously, in certain scenarios, some agents are required to work in an adversarial way. Relevant information is shared between different conversations in a controlled manner, preventing distraction or hallucination. A2, A6. AutoGen supports both patterns, enabling effective utilization and augmentation of LLM. 5.1 General guidelines for using AutoGen. Below, we give some recommendations for using agents in AutoGen to accomplish a task. 1. Consider using built-in agents first. For example, assistant agent is pre-configured to be backed by GPT-4 with carefully designed system message for generic problem solving via code. The user proxy agent is configured to be able to solicit human inputs and perform tool execution. When combining these 2 agents, many problems can be solved already with a decent performance. When customizing them for an application, consider the following options. 1. Human input mode, termination condition, code execution configuration, LLM configuration, or easy to specify when constructing an agent. 2. AutoGen supports adding pinned and initial user message, which is an effective way to boost performance without needing to modify the system message. 3. User proxy agent can be extended to handle different execution environments and exceptions, etc. 4. When system message modification is needed, consider leveraging LLM's capability to program its chat flow with natural language. 2. Keep the agent chat topology as simple as possible, as well as reduce code-based extension. Consider using the 2-agent chat or the group chat setup first, as they require least code-based extension. Note that even the 2-agent chat setup can involve more than 2 agents by using LLM consumable functions in a dynamic way. When more control of the chat flow is needed and the desired control cannot be achieved by all the conversation programming suggested, tweaking system message and LLM consumable functions, then one can consider registering custom auto-reply methods. 3. Try to reuse existing auto-reply methods based on LLM, tool, or human before implementing the custom auto-reply methods, because they can often be reused to achieve the goal in a single way. E.g., the built-in group chat manager's auto-reply method reuses the LLM-based auto-reply when selecting the next speaker. Ref. A5 in section 4. Also, try to leverage the automated chat as much as possible when defining a custom auto-reply method. For example, as a single initiate chat triggers an entire series of chat, one can define behaviors more easily than defining each single message passing event. 4. When developing a new application with user proxy agent, start with humans always in the loop, i.e. human input mode equals always, even if the target operation mode is more autonomous. This can help understand the effectiveness of assisted agent, tuning prompt, discovering corner cases, and debugging. When confident with small-scale success, consider generating diverse test cases by setting human input mode equals never enable LLM as a backend, and either use LLM or manually generate diverse system messages to simulate different use cases. 5. Despite the numerous advantages of AutoGen agents, there could be cases, scenarios where other libraries packages can help. For example, 1. For sub-tasks that do not have requirements for back-and-forth troubleshooting, multi-agent interaction, etc. A unidirectional, no back-and-forth message exchange pipeline can be also orchestrated with LangChain, reference 24, Llama Index, reference 31, guidance, reference 18, semantic kernel, reference 43, Gorilla, reference 40, or low-level inference API, AutoGen. OAI provides an enhanced LLM inference layer at this level, reference 13. 2. When existing tools from LangChain, etc. are helpful, one can use them as tool backend for AutoGen agents. 3. For specific applications, one may want to leverage agents implemented in other libraries packages. To achieve this, one can map those agents as conversable agents in AutoGen and then involve them when building LLM applications through multi-agent conversation. 4. It can be hard to find an optimal operating point among many tunable choices, such as the LLM inference configuration. Black box optimization packages like Flamel, Tune, reference 48 can be used together with AutoGen to automate such tuning. 5.2. Future work. This work raises many ideas for future directions and research questions. Here we elaborate on 3. Designing optimal multi-agent workflows. Creating a multi-agent workflow for a given task can involve many decisions, e.g., how many agents to include, how to assign agent roles and agent capabilities, how should the agents interact with each other, and whether to automate a particular part of the workflow. There may not exist a one-fit-all answer, and the best solution might depend on a specific application. For example, in section 4, creating a multi-user application for solving math problems. A1. Scenario 3 required a very different workflow from creating agents that can solve web interaction tasks. A3. This raises important questions. For what types of tasks and applications are multi-agent workflows most useful? How do multi-agents help in different applications? For a given task, what is the optimal, e.g., cost-effective multi-agent workflow? Creating highly capable agents. AutoGen can enable development of highly capable agents that can leverage strengths of LLMs, tools, and humans. Creating such agents is crucial to ensure that a multi-agent workflow can effectively troubleshoot and make progress on tasks. For example, we observed that Camel, another multi-agent LLM system, cannot effectively solve problems in most cases primarily because it lacks capability to execute. 11. This failure shows that LLMs and multi-agent conversations with single role player insufficient and highly capable agents with diverse skill sets are essential. We believe that more systematic work will be required to develop guidelines for application-specific agents, to create a large knowledge base of agents, and to create agents that can discover and upgrade their skills. Reference 11. Enabling scale, safety, and human agency. Section 4 shows how complex multi-agent workflows can enable new applications, and future work will be needed to assess whether scaling further can help solve extremely complex tasks. However, as these workflows scale and grow more complex, it may become difficult to log and adjust them. Thus, it will become essential to develop clear mechanisms and tools to track and debug their behavior. Otherwise, these techniques risk resulting in incomprehensible, unintelligible chatter among agents. Reference 25. Our work also shows how complex fully autonomous workflows with AutoGen can be useful. However, fully autonomous agent conversations will need to be used with care. While the autonomous mode AutoGen supports could be desirable in many scenarios, a high level of autonomy can also pose potential risks, especially in high-risk states applications. Reference 450. As a result, building fail-safes against cascading failures and exploitation, mitigating reward hacking, how to control undesired behaviors, maintaining effective human oversight of applications built with AutoGen agents will become important. While AutoGen provides convenient and seamless involvement of humans through user proxy agent, developers and stakeholders still need to understand and determine the appropriate level and pattern of human involvement to ensure the safe and ethical use of the technology. Reference 21. 3. Finally, AutoGen is an open source, community-driven project under active development and aims to provide an effective and easy-to-use framework for developers to build next-generation applications. This work underscores the significant potential of AutoGen in achieving this vision. AutoGen encourages contributions from individuals of all backgrounds to build such affordances. Ethical implications. There are several potential ethical considerations that can arise from the development and use of the AutoGen framework. Privacy and data protection. The framework allows for human participation in conversations between agents. It is important to ensure that user data and conversations are protected and that developers use appropriate measures to safeguard privacy. Bias and fairness. LLMs have been shown to exhibit biases present in their training data. Reference 35. When using LLMs in the AutoGen framework, it is crucial to address and mitigate any biases that may arise in conversations between agents. Developers should be aware of potential biases and take steps to ensure fairness and inclusivity. Accountability and transparency. As discussed in the future work section, as the framework involves multiple agents conversing and collaborating, it is important to establish clear accountability and transparency mechanisms. Users should be able to understand and trace the decision-making process of the agents involved in order to ensure accountability and address any potential issues and biases. Trust and reliance. AutoGen leverages human understanding and intelligence while providing automation for conversations between agents. It is important to consider the impact of this interaction on user experience, trust, and reliance on AI systems. Clear communication and user education about the capabilities and limitations of the system will be essential. Reference 9. Unintended consequences. As discussed before, the use of multi-agent conversations and automation in complex tasks may have unintended consequences, especially allowing LLM agents to make changes in external environments to code execution or function calls, such as install packages, could be risky. Developers should carefully consider potential risks and ensure that appropriate safeguards are in place to prevent harm or negative outcomes. Societal impacts. Widespread use of capable AutoGen agents may displace certain human roles and jobs, and access to such powerful automation could raise issues around digital divides. Ongoing research into the societal effects of AutoGen and similar technologies is warranted. Acknowledgements. The work presented in this report was made possible through discussions and feedback from Doug Berger, Umesh Madan, Ahmed Awala, Robin Moore, Payali Chowdhury, Selena Amershi, Adam Forney, Victor Divya, Ryan White, Woching John, Corby Rossett, Ricky Warren, John Langford, Ida Momen, Brian Krabak, Taylor Webb, Shankar Subramanian, Ian Lee, Yu Wang, Suman Nath, Tanakor Lisa Adewansa, Shin Wang, Shashir Patel, Tianjun John, Ishai Nash, Konstantin Melu, Rulong Joe, Farron John, Jiali Liu, Ham Condor, Hamid Delangi, Srinaga Sharma, Julio Alvanachi Cortez, Amin Sai.
Okay, that's just a bunch of names. Very good paper. I can see why it's so popular. 16,000 stars. But also it's kind of cheating because it was mentioned by Satya. It's a Microsoft-backed project. It's a little bit of cheating, but it is a good paper. So very well deserved. What else can I comment about it? I really liked the 6 examples that they gave. It was a lot of diverse use cases. I probably liked the RAG stuff the most and the chess stuff next. The math was pretty good. Like that was also like a good demonstration, I guess, of what it was. Where's the list of scenarios? Yeah, it was very well done, very well maintained. I mean, very well explained. I don't know about the maintenance. I was trying to look for the dependencies, and do they have no dependencies? Because I look at Pi Project, um, they got jack shit. They don't seem to have the requirements. I look at Setup Pi. Um, Nothing crazy. Tick token, term color, flammel. This is nothing. So yeah, like basically zero dependencies. Um, they use Chroma, replicate pillow. Nothing crazy. This is like surprisingly light, um, so very self-contained. Um, wait, where's the code? Oh, this is 2 agent code. Wow. Then you have a config list. Okay. There's an assistant agent and a user proxy agent. Um, Assistant agent is a subclass of conversible agent configured with the default system message. It's like nothing in it. What is a conversible agent? Oh boy. Yeah, this is chunky. Yeah, this is the whole thing. Yeah, I disagree with this like number consecutive auto. I guess this is a hard limit, but there might be some kind of other auto reply function. It might be good. Default auto reply. Okay, cool. LLM config, sure. Register reply. Yep. Yeah, here. Yep, this is how I would do it. This is how we do it. This is how we do it. It's Friday night. If a class is provided, it will be called when the sender's instance. If string is provided, it's the name. Agent instance provided, what we call it the instance match. Callable is provided when the callable returns true. If a list is provided, and any of the triggers in this list is activated. If none is provided, I feel like callable is this kind of superset of all these things. This is how we do it. This is how we do it. Use Docker. Wow. Use Docker to execute the code. Dun, dun, dun. Bum, 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 ba-dum, bum, bum, ba-da, bum, bum, ba-da, bum, bum, ba-da, bum, bum, ba-da, bum, ba-da-da-dum, bum, ba-da-da-dum, dun-dun. Just a small town girl living in a lonely world. She took the midnight train going anywhere. Just sitting there, a singer in a smoky room. A smell of wine and sweet perfume. For a price he can share the night. It goes on and on and on and on. Strangers waiting up and down a boulevard of your shadow, searching in the night. Street lights, people living just to find emotion, hiding somewhere in the night. Dun, 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 working hard to get my fill. Everybody wants the thrill. For a price he can share the night. It goes on and on and on and on. Strangers waiting up and down a boulevard of your shadows, searching in the night. Cool. Can't believe I just read the code. Hey, that was good. That was really good. User proxy agents. Nothing crazy there. Group chat. Yeah, this is the orchestrator, right? It's 200 lines of code. So you define the agents, self.agents, store it in there. Yeah, this is great code. Select speaker. Bottom, a singer in a smoky room. The smell of wine and cheap perfume. Fantastic. Okay, love it. Looks like he mentioned it 8 days ago. Where's the Satya thing? Okay. The only other thing I want to see with regards to this, obviously, I think very worthwhile paper, very very good framework. I wonder what their plans are going forward for this. They seem OpenAI centric. It's amazing that Light LLM hasn't got to them yet. Human input mode always seems weird. Human input mode never also seems weird, but it seems like too big of a toggle to just shift like that. That would be my 2 cents there. Oh, I love these. Yeah. Look at that. It's hot. This is the screenshot that I'm going to use for the thumbnail of the YouTube. I didn't really get these two, I think, but these were all great. And they have notebooks for each. Marry me. Marry me, my in the storm. There'll be peace when you are done. Lay your query head to rest. Don't you cry no more. Are you fine tuning? What is this tuning? What does tune do? That doesn't say shit. Wow, a seed that is not 42. crazy. We're getting crazy here. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Carry on my wayward son. There'll be peace when you are done. We are very hard to rest. Oh, hyperparams. Oh, you're tuning hyperparams. That is expensive. Don't you cry no more. What a valiant effort. What did you decide? 5.22222. What is 5.22222? All right. Pointless. Okay, blog. The thing that I actually want to see is what they said on about GPTs. There's also Eco Assistant. What is this? Okay. Like leveraging external APIs is cool. Multimodality. Wow, these guys have been busy. Carry on my wayward son. There'll be peace when you are done. Lay your weary head to rest. Don't you cry no more. I love this. This is great. Lay your weary head to rest. Don't you cry no more. Okay. How is this implemented? Carry on my wayward son. There'll be peace when you are done. Lay your weary head to rest. Don't you cry no more. What the hell is analyze? I love this. This is a secret killer right here. Wow. Carry on my wayward son. There'll be peace when you are done. You will be here to rest. I'm going through AutoGen code base. Nice use. Really nice usage of Chroma. See here. Let's see blog post and notebook. Fuck. Sorry, I'm doing something off screen because I'm messaging someone. The Chroma people need to check out this repo because it's really cool. It looks like I cannot link my machine. Link devices. Link new device. New device. Send, retry send, retry send, retry send. Okay, cool. All right. Yeah, this is great. I wasn't even intending to come here, and then it sidetracked me totally. But this is fantastic. And then the rag. This one I think we already saw. This is in the paper. This is in October, so it's in the paper. What does it use to rag things? Docs path is at README. Where's the LLM config? Don't you cry no more. Yep, well done. It's under a beta. Oh. Okay. Non-core agents. Okay, so wait, I'm not as on board with this. What is the value here? Okay, so someone in the comments says, "Hey, Robert Soriano says, hey, so I'm giving a talk in our town soon about AI engineering 101. Can you tell us what is software?" Yep, that's exactly what it is. The main chart that everyone should have in mind is this chart. Uh, Mostly people from the right going to the left, and then the ML people are going to be staying in demand. We've also recently added AI for Engineers, which is a course, and then we put up our AI Engineering 101 workshops, as well as 201 and 201B. So if you want to check those out, those are where I worked with these two instructors to sketch out a curriculum. There's also another guy who is building a more intense curriculum um, here. This one is like a 14-unit curriculum that he's building. Maybe I should also put that in there. So I'll just promote his curriculum here. So Rod Rivera. So Unit 1, Unit 2, Unit 3, Unit 4. I told him to put the foundational and the safety stuff towards the end, because that can be a little bit intimidating for people just starting. I want you to get as quickly as possible towards something like a RAG, something like applications, something like code gen, content generation, like the use cases first before the safety stuff. So I will promote this guy. And then I'll just edit this here. Other AI Eng curriculums from the curricula community. Contact 6 if you want review and help promoting. Like Rod. There you go. Done. Let's go. All right. Hope that answers your questions. Thanks, Robert. Good luck with your workshop. So yeah, okay, I'm almost done with this session. This has gone longer than I intended. This one doesn't seem as valuable. This one just, they put a very, very thin wrapper on top of the assistant API. Maybe their abstractions for like communication between the user proxy and the GPT assistants is useful. But here, this is not useful at all. Sorry. Okay, that is it for today. We only got through 2 papers. The last one wasn't that important, I don't think. I mean, I can just quite quickly do a visual scan through this. What is this? What are those? Generalized agent learning abilities. This is from Tsinghua. We present agent tuning, a simple and general method to enhance the agent abilities. LM or mini. We construct the agent instructor, live instructor, Llama 2 series, agent LM. Our evaluations show that agent tuning enables LM's agent capabilities. Agent 7V is compared to the scene agent task. All right, cool. Fine tuning thing. Big jumps in some capabilities that only they care about. GPT 3.5 is still pretty goated, but then what about GPT-4, yo? Oh, crushed. Wait, where's Agent LM? You didn't put your own shit here? Okay, where's GPT 3.5? 3.5 is 2.55. Okay, I mean, like, GPT-4 is going to be pretty good. Yeah, I mean, it would be nice to review this paper. It's 31 pages. I don't have the time. So anyway, I think AutoGen is like still the useful one. This is for this agent tuning thing is more for fine tuning agents. I think still relevant. I'm going to put it in my notes. My notes for agent stuff is just really bad. So I'm just going to fine tuning for agents reasoning. And I'll call this agent tuning. Da, 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 da. Da, 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 and then I commit all my notes to GitHub, and then you can see my notes at AI-notes. So in case you ever want to see where I commit all my notes stuff, it's just all here. Okay, that was it for the session. There are probably a couple dozen of you who stopped by. Thank you for watching. Sorry for the noise. I do have to sync to think. That's it. Good night.